Welcome to the Rim Break Rodeo. We hope this video helps.
You begin by preparing the environment and instruments so you can harvest ambient dark matter signals without unlocking sealed caches. Start the containment rig and enable passive sensors. You want minimal disturbance. Once the rig stabilizes, introduce particle filters to bias for weakly interacting candidates while keeping interlocks engaged for safety. Make sure to run a 10-minute background scan and record temperature and pressure. That baseline explains noise, so later signals stand out. This initial stability is why controlled inputs matter. Now you run the controlled collection sequence that extracts candidate events without unlocking sealed systems. You tune low-threshold detectors to key V-MeV sensitivity and sample at 1 kHz so transient interactions register. This increases capture probability for weak signals. Once done, introduce subtle magnetic shielding modulation to create predictable flux gradients that separate background from signal. Record exact timestamps. Then stack results across roughly 1,000 short trials to improve signal-to-noise ratio, which is why repetition matters for faint accumulations. To finish, you aggregate the stacked spectra and apply coincidence filters within defined time windows to isolate persistent peaks that indicate dark matter candidates. Make sure to cross-check each candidate against the baseline and a cosmic ray veto to exclude common false positives. This differential check explains why vetoes are essential. If detections remain ambiguous, increase trial count by 5 times and tighten shielding to reduce background. Then reevaluate. Troubleshooting tip: if noise persists, swap detectors and rerun a 30-minute baseline to identify hardware artifacts.
Thanks for watching. Consider subscribing if we helped you.